Let's talk about a classic geometric series problem where we have a ball that is dropped from a height of 10 meters and each successive bounce is 80% of the previous bounce. What we're trying to find out is, well, algebraically determine the height of the ball after the fourth bounce, and then part B says algebraically determine the total distance when the ball contacts the ground for the first time. So let's tackle this first part. Here we have A after the first bounce. So let's see what we have. We have the ball dropping down a height of 10 meters. So that's 10 meters right there. And then it returns to a height of 80%. Now it's going to bounce. So I think I'm going to just say it's going to bounce again here and then bounce again like so. Bounce again the fourth time, and then it comes down on the fifth time. Here I'm going to change to a different color, and notice that after the ball bounces, it's going to come back up to this height, and then the ball will bounce again and come back to this height, and then come back to this height, and then come back to this height. Now for the sake of convenience, I did all the blue ones and then the red ones, but you can see that the red heights here are the heights after each bounce. Now what I'll also do is consider, let's see if we can put this phantom red height here where we've taken the ball up to 10 meters. So we want to find the height of the ball after the fourth bounce. So it comes down, the ball bounces back up the red path, and then comes down and bounces again. This is the second bounce. This is the third. This is the fourth, and this is the fifth. So this is the first bounce. This is the second. This is the third, and this is the fourth bounce. So what we're looking for then specifically is that we're looking for this. I'll just use a different color here. We're looking for the red height right there. And so if we take a look at the numbers here, if we take a look, this was the very first number, 10 meters. This is the second number. This is the third. This is the fourth. And when we're taking a look at this height after the fourth bounce, that's actually our fifth number. And so we can think of it as T5. Now I'm using blue here, but remember we could use also the red. We can see that this red height is the height that it reaches after the bounce. So this is the first red height, the second red height, third red height, fourth red height, and the fifth red height. So we can say that's T5 here is the height after the fourth bounce. Now according to our geometric sequence formula, we have Tn is equal to AR to the n minus 1, which means that if we're talking about T5, then you have the 10 meters, this phantom 10 meters for the red, but it's also equal to the blue here. And then what is our R? Well, R, since it says that it bounces back to an 80% of the height, and that means we can use 0.8 as our common ratio, and we have term 5 minus 1. And so this is 10 times 0.8 to the exponent 4. Let's see what 0.8 to the exponent 4 is. I believe it's 0.4096. And that times 10 is 4.096. And we're in units of meters. So we can say that T5, this is the height after the fourth bounce. And you can see again, here we're using this as the very first one, which is equal to our 10 meters. And this is the height after that first bounce. This is the height after the second, but you can see that it's term number 3. This is the height after the third, which is term 4. And this is the height after the fourth bounce, which is term number 5. Now let's tackle B here. Algebraically determine the total distance when the ball contacts the ground for the fifth time. Now let's try and consider what's going on here. So if we're talking about the total distance, what we mean is we want to add up all the blue down distances, and we're also adding up all the red distances. So here the total distance is this blue, then red, blue, red, blue, red, blue, and then red, blue. Now what I'd like to do though is I'm going to add this phantom red height. It's not originally in the problem, but I'm going to add that red phantom height in there so that each blue downstroke has a partner red up height. So what we can think about then is that the total distance is equal to all the blue, so blue plus the red, and here, because we had the red here, we're going to minus that initial. Now you can ask yourself, well, why did I add this and then I'm going to subtract it afterwards? Well, since we have a partner for each blue, we can think of just the blues as a sequence on its own, and we can get the sum of that sequence. So everyone has a partner. So we're looking at 2 times the sum of all the blues. So we can say S of blue, and that takes care of all the blue, all the red, if we've included this phantom red here. And then we can subtract that phantom red 10 that we added here with the dashed line. So let's follow that formula and say, okay, well, what are all the blue downstrokes altogether? Well, the formula for a sum of a geometric sequence is a bracket r to the n, then a minus 1, all over r minus 1. Here, I'll just keep that going. 2 times, and what is the original height? Well, the way I set it up, I said that the original height was 10 here. So this is 10. And then we have r, which is 0.8. To the exponent, well, when it contacts for the 5th time, we're actually summing all 5 terms here. So this is going to be 5 and minus 1. And then that is over top of 0.8, the common ratio, minus 1, which ends up being 10 times, what is 0.8 to the exponent? 5. This is 0.32768. Then subtract 1, and then we have that over our negative 0.2. That's 0.8 minus 1. And of course, we're going to be minusing 10 as well. And the minus 10 is this phantom red height. So we continue this on. Let's see if we can make it go over here. So I'm just going to put an arrow and it goes right to there. We have 2 times our 10 times 3.2 minus 1. Well, 0.32768 minus 1 is going to be negative 0.67. I think there's more to it. 67232. And then that's over top of negative 0.2. Remember that this is also going to be subtracting 10, and it's a red 10. So we have 2 times and negative 0.67232 divided by negative 0.2 is going to be 3.3616. 3.3616. And remember that minus 10 is going to be still there. This is 2 times 10 times 3.3 is 33. So we have 33.616. Of course, this is going to be minus 10. So 2 times 33.616 is 67.232. And we're going to subtract 10. And now I'm just going to make it a 10 so that we know that why we're subtracting the 10 is we added this red phantom height to be a partner to this first blue, and then we could say that all of this, the sum of the series here of the blues doubled, is all of that together. But this is not included in the problem. We just added it in so that we can make a nice double, and then we're going to subtract that off. So here we have 67.232 minus 10. That's 57.232. And so we can see the total distance that the ball travels as it contacts the ground for the 5th time is going to be 57.232 meters.